All right, welcome to our lecture. And tonight we have some interesting topics. We have the time value of money. And there's a lot of things involved with the time value of money. Starting off, it's really the foundation of finance. We have a lot of things to learn about it. And starting off, I usually tell everyone to look at the simple concept of if you were offered $1 today or $1 tomorrow, which would you choose? And maybe stop and think, is there a catch to this? And I would too. And in the end, you would probably say, I want the dollar now. And if you look at it that way, in a much more complex method based on formulas and theory, you'll see that there are risks to getting the dollar tomorrow. Getting the dollar tomorrow may mean that you could have earned interest on it today. You may have invested it and gotten very rich overnight. There's also risk in getting it tomorrow, right? Possibly the person that was going to give you the dollar won't pick up the phone, won't answer your messages. The deal is off. So that's just a simplified explanation of the time value of money. It has a time value, and we look at some concepts such as present values of annuities, present values of annuities due, future values. Sometimes we have some multiple streams of income going on. And we see that we can do these calculations in so many ways. We can do them using formulas by hand with long mathematical formulas that show the amount of money, the time periods, the interest rate to use. I really doubt anyone's going to sit and do them that way. However, it is a way to get the answers. There's also tables, and tables are really cool, actually. You probably won't use those either, but they're nice to Google and see what they look like. Let me see if I can get one handy and show you. They're really not used very much, but okay, I'm going to share my screen and show you, because I really think that they show you a lot. They really do. Even though it's a little bit old school, I was trained on tables. So here you go. You just look at, and again, you'd have to know the present value, what you're looking for, but you assume that it's for $1 because we can't print out a table for every single dollar amount that you're going to need to calculate. So for simplicity at the time, the tables are published for $1, and then you just multiply for the number of dollars that you're actually dealing with. And then you look at the period, how many periods it's going to compound over, usually in years, let's say 5 years. And then the interest rate. So let's say the interest rate was 5%. So where all that crosses together, you get the factor of 0.82270. You multiply that factor by the number of dollars, because this is only for $1, this table. It's really just something I wanted to share. I don't anticipate that you'll be using the tables, but you can say that you saw it, or if you have a finance person in the family that even a grandparent, you can tell them You've seen the tables, and they have them for future values and annuity due. And I mean, they show you exactly. You can see the trends as the interest rate increases, what happens as the time period on this axis increases, what happens. It can tell you a lot. So anyway, I didn't expect to share that, but it is actually a very good thing to see. I'm glad that I learned with tables because it gave me a nice foundation. So, all right, so let's get into chapter 5. I have up here. It's a good PowerPoint on the time value of money that I found. So we will go through it, and also I have a video for you guys too. All right, so hopefully that fills up your screen. And the time value of money. Let's see what Gitman and Zutter have to say about the time value of money. So the learning goals and objectives for this material is to learn about the time value of money in finance, the use of computational tools, the basic patterns of cash flows, future value, present value for single amounts, future value and present value of both an ordinary annuity and an annuity due, and the present value of a perpetuity. That's one I didn't mention yet, perpetuities. They're really cool too. Present values and future values of mixed streams of cash, and that's a little more complex, but that happens too. Understanding how compounding affects everything, and then describe the procedures involved in determining deposits needed to accumulate a future sum. So it's when we're doing some planning, we know how much we need to, let's say, put our kids through college, and we need to know we're going to need, maybe, I don't know, by the time our kids go to college, let's say 100,000 or more, right? So depending on how young the child is, the time value of money will show you how much to save so that you reach your goals. Also, loan amortization, which is very common if you've ever gone for a mortgage, or they even sometimes show amortization schedules and other loans too. And then finding interest and growth rates. So that's the objectives in the material. So here's future value versus present value, and we have a little table up here. Suppose the firm has an opportunity to spend $15,000 right now on some investment that will prove $17,000 to provide to you, spread out over the next 5 years as follows. So we have year 1 through 5. The cash flow they're presenting is $3,000 in year 1, $5,000 in year 2, $4,000 in year 3, $3,000 in year 4, and $2,000 in year 5. And they're asking, is it a wise investment? So in making the right decisions, we see that the managers need to compare the cash flows at a single point in time. So now we have our timeline with the different cash flows going out to our 15,000 going out minus 15,000 at time 0. So we see that managers are usually going to calculate present values. This can be done another way. Here's another way, besides our tables, which I really, like I said, didn't even plan for, but just felt in the mood for those because they're just so classic. Okay, so again, a little bit, they're used. The calculators are still really popular, I have to say, even though you can have an app on your phone, but it's going to be the same concept as the calculator. But if you find that you do these calculations often, I like having my financial calculator. And the most common one, there's an HP Hewlett-Packard, and there's also a Texas Instrument financial calculator. And they're probably available on Amazon or lots of places, but they're just so easy to use. And there's other ways to do this too. You can do them in Excel also, but I find the calculators to be even easier. So we just have to know what the numbers mean, the designations, where we enter the amounts. And here is the key. For the N, it means the number of periods. So if we're going to have 5 years, we'll put in 5 and then press the N key. The I for the interest rate for each period. And so let's say it was 5%. Press 5% in the I key to enter that in. Present value, PV, payment, and that's only used for annuities. How much is the payment? Future value, press that button. And then compute. There's a slight difference between the two calculators, maybe even a little more than slight, but these are the common designations to use. And every calculator will have instructions with it. I used to use the, which one? Let's see, the HP, and it was always trickier, but sometimes I found that it did more. And so even though the Texas Instrument was easier to use. Next, we have electronic spreadsheets like Excel, and they have built-in routines that simplify the calculations. So the good thing about Excel is that we see that everything, if you look down to this bullet point, if we make one change, it's going to change over everything that's linked to it, which is great. You start entering a bunch of things into a calculator. You don't have anything on paper or on a screen that shows what you did in the prior keystrokes that easily. Excel would be great if it's a real big project, because you're going to have everything on the screen in front of you, or you can even print it out, do whatever you want with it and save it, which you can't do on the calculator. So Excel is a great tool. And all of the functions for finance that we discussed today are easily done in Excel too, all of them. Cash flow signs to provide a correct answer. The financial calculators and spreadsheets require that a calculation's relevant cash flows be entered accurately as inflows or outflows. So if we have inflows, we're going to consider them positive, and if we have outflows, money going away, they're a negative sign. Makes logical sense. We have 3 patterns for cash flows. We have the single amount, and that's where we have the lump sum, one large amount that's either we have right now, $5,000 we have right now, we want to invest, see what we can do with it at a certain interest rate over 2 years, 5 years, whatever. And then also when we're looking to reach a certain amount, like the amount for someone's education in 10 years at a future date. Onto the annuity, that's the level periodic stream of cash flows. So it's a payment that you're going to get, let's say every month, and you can count on that for X amount of years. You need to know the interest rate and the term. The mixed stream is just when you have unequal cash flows. And we mentioned that earlier. So future value of a single amount. We see that that's the value at a given future date of an amount placed on deposit today and earning interest at a specified rate. We see that we have to apply compound interest over that period of time. And that's what's going to help your money grow, right? That there's interest on interest. Each time that your principal grows, that becomes your new principal amount, is the principal plus interest that you previously earned. An example here is a good example. We have Fred places $100 in a savings account. This slide must be really, really, really old because it's paying 8% interest compounded annually. I don't think that anyone here can really say they recall that time period when they could make 8% on a savings account. It's been quite a while. So how much will we have at the end of 1 year? We want to know future value, right? So at the end of year 1, it's $100, the amount that we put in the account, times 1 plus 0.08, the interest rate, 8%, is $108. Future value at the end of year 2, we just have to show $100 and do the calculation of the 1 plus 0.08 twice. So we come up with $116.64. You see how the money's really growing, right? Some other notations. Future value, subscript N is the future value at the end of period N. Present value we know is the principal or present value. R is the interest rate. And just to remember that I, like we said earlier, is very oftenly used on the calculators for interest. And it's the number of periods, primarily years, depending on how many compounding periods there are. But for simplicity, we can look at it for years for now. And then the equation for the future value, which again, this is when we do it by hand. Future value is equal to the present value times 1 plus r to the nth power. And what I'll do right now is I'll show you the video that I have for you guys. I will find that and okay. And adjust your volume too if you need to for this. It's a really good video. Ignore their name. Their name is a little bit ridiculous, but their videos are really easy to understand. That's why I like them, and I wish they changed their name. But they really put things very clearly. And what they're discussing is one of our more complex topics in finance. And it's the capital asset pricing model, and they explain it very well. So adjust your volume, your screen size. Here we go.
Our topic will be on or about APM, or the capital asset pricing model in the field of finance or financial management. Management sounds scary and complicated, but don't worry, this is just MBA bullshit, and we can cut through the bullshit and you can see how easy and simple it actually is. Okay, so just remember, you can always come here, whether you're a business student from your previous MBA, you just want to learn, okay? So now let's go to the capital asset pricing model. Now, most professors will explain the capital asset pricing model, or CAPM, as a formula, which looks like this. Now, I know that this formula over here can look very scary and intimidating, but please do not panic, because this is actually very simple when I show you step by step how easy it actually is. Okay, so don't worry about it. But in order to allow you to understand it well, I want you to first remove this complicated bullshit from your brain right now, temporarily. We'll get back to it later. Remove it from your brain. Don't panic. And I just want you to look and focus. I just want you to focus on this other thing I'm going to show you now, okay? You're going to see it's not complicated at all. So I'm going to start by telling you a story. And in the story, I'm going to give you a choice. Let's say I offered you a risk-free investment, okay? It was an investment or it's an opportunity for you to earn money by putting your money in my bank. You have a deposit account in my bank, and my bank is guaranteed by the government, and so therefore it is risk-free, zero risk. Okay, for sure the bank will not collapse like what happened in the recent economic crisis. In this case, you are 100% sure that the bank would not collapse. Okay, and you have the opportunity, you have the offer to deposit your money in this bank, and the bank will give you an interest of 2%. Okay, so the 2% here is what we call the risk-free rate. Okay, so let's just say that you can put your money in my bank has no risk, and you can earn 2% interest, or 2% income, or 2% profit on your money by depositing that money with this bank. And then I give you a second choice, okay? I give you a second choice with an investment which has medium risk, okay? And for this example, let's just say that the United States stock market, the general stock market, has medium risk. So the bank here, the bank deposit has no risk or zero risk, and the U.S. general stock market has medium risk, which is also called systematic risk. Now, don't worry so much about the systematic risk here. This is just MBA bullshit, and for now, let's just use the word medium risk, and we can get back to the systematic risk later. Now, it's called systematic risk because it represents the risk of a certain system which is usually used, such as the United States stock market, okay? But if you don't understand what I just said, don't worry about it. Just forget it for now. For now, we'll just say it's medium risk. Now, what if I also offered you, I offered you a risk-free investment, a zero-risk investment or deposit earning 2%, and I also offered you a medium risk investment. And this medium risk investment would earn you also 2%. Okay? It would also earn you 2%. So if you had to choose between this investment here or this investment here, which one would you choose? Which one? They earn the same amount, but this one has higher risk than this. Well, if you have at least some intelligence, then for sure you would choose, you would choose this investment and not this one. Why? Because in this investment, you earn 2%, but you have no risk. In this investment, you also earn the same small profit of 2%, or you expect to earn the same small profit of 2%, but you have even higher risk compared to this one over here. So of course, it makes much better sense to put your money here in the no-risk investment. Okay? So let me ask you, let's say I was a stockbroker in the United States who trades stocks in the United States, And I want to convince you to move your money away from here and instead put your money here. How would I do that if I'm only giving you 2%? Well, of course, the normal way would be for me to try and offer you more than 2%. And I'd try to offer you extra money, extra profit, or an extra percentage here. That way, it will be worth it for you to move your money from here to here. Because now you're earning more profit in order to pay you for the extra risk. Okay? So for this example, let's just say I offered you an extra 6%. Okay? So I offered you an extra 6% return or an extra 6% profit on your money to place your money here instead of here. Okay? So now these two investments have equal attractiveness. Okay, let's just call it equal attractiveness. Because here, you only earn 2%, but you got no risk. Here, you earn 2% plus 6%, but you have medium risk. And medium risk is more than no risk. So now, these two choices should have equal attractiveness.
Okay. Now there's a few more parts to that video. They have part 2 and 3 to CAPM, and I recommend them highly. I really do. Again, I have a little problem with their name, but I'm sure they don't care when they have so many viewers. It gets some attention. So let's see where we were with the PowerPoint. Hold on one second. Okay. So here's an example. We left off, this is one in personal finance. We have Paul who has $300 to receive 1 year from now, 6% on his investments. What is the most he should pay now for this opportunity? And if we look at the formula, present value times 1 plus the interest rate is $300. And the present value is equal to 300. That's what he had the amount to receive. Times 1 plus the interest rate is equal to 283.02. This is the equation for the present value of a single amount. Not that you'll do it that way. And I want to get into annuities. Let me just spend a minute on annuities. Annuities, like we said, are periodic payments that we receive, possibly monthly or quarterly. Usually they're equal and they're regular, although there are variations. The key to knowing the two types is the ordinary and the annuity due. The ordinary is the more common one, and it pays at the end of each period, but the annuity due begins right away. That's the only difference. You have to use different keys on the calculator or in the tables or in Excel, because if you're getting the payment at the beginning of the month, let's say you invested today and you get your first payment right away, then that's of course going to differ as if you get it at the end of the first month. And there's an example of this too, but I want to get to something else. Let's see. Perpetuities, just so you're familiar with perpetuities. And perpetuities they exist. They're not that common, but they exist, and it's a financial term. It is an annuity, so you're getting these payments, but there is no ending. You're getting them forever. And that's kind of an interesting concept. It's amazing that there's a formula for that, right? It's amazing if you were lucky enough to have a perpetuity coming in. So the formula that we use for that is present value, PV, is equal to the cash flows divided by the rate. And we have an example. And this is an example that happens most commonly for perpetuities. Let's say this person wants to donate money to their alma mater, and the university indicated it requires $200,000 per year, and the endowment would earn 10% per year. So you want to determine the amount that Ross Clark has to give the school to fund this chair. And here we see the formula in place. It would be $2 million. The perpetuities are really cool. And there's other examples of, besides that university, it can be a hospital donation, it can be a lot of things. Lastly, be aware of these two types of interest rates. There's the nominal or stated rate, and then the EAR, the effective annual rate. So in certain problems, they'll be asking for one or the other. Just be mindful that you might see either one. That's about all that I have for us. Again, the key topics, the time value of money. We can use many different ways to come up with our solutions, either the formulas by hand, the tables that I showed you, Excel, financial calculators, and then also our introduction to the capital asset pricing model. And I do encourage you to watch more video on it, either from the source that I got it from. They have subsequent parts, or some others too are really good, but they were very lengthy. So CAPM is also in your readings too. And thanks for listening. I will see you guys soon.